Okay, we're going to learn today about slope, midpoint, and distance. Okay, so we actually have formulas for all these. So this is slope, which is actually an M in a formula. It's going to be your rise over your run. So how far do you rise up between points and how far do you run is the cross move. So rising would be the difference in your heights, and running is the difference in your x's. Midpoint, so halfway between. Okay, so you're going to take adding your two x's and averaging them, and adding your two y's and averaging them. And your distance is Pythagorean theorem. So if I think about 2 points, okay, this is the distance between them, and this is my rise, and this is my run. And then you're going to think about a squared plus b squared equals c squared. So what is rise? The differences in your heights. And run is the differences in your x's. Okay. So don't forget at the very end though, you're going to have to square root this to actually get that number. So that's why your formula is the square root of a squared plus b squared. So it doesn't matter which order here you go in. A squared plus b squared. Pythagorean theorem, but obviously to get your final answer there, you square root it. Okay, so here's an example. So here's 2 points. So I'm a very visual person, so I'm going to actually draw these. So -1, 2 is right there. Okay, so there's our points. So the slope between them is our run. Okay, so I'm going to label this. This is the x coordinate, and this is the y, that's an x and the y. So we could just call this point 1 and point 2. Okay, so this means it's the x coordinate of the first point, the y coordinate of the first point, x coordinate of the second point, y coordinate of the second point. Okay, and we could just fill in. So 5 subtract 2. 3 subtract -1. So 5 subtract 2 is 3. Don't forget here, subtracting a negative adds it. So then that's 4. So the slope is 3 over 4. In other words, to physically move from this point to that point, I had to go up 3, right 4. And it does get me there, right? Physically, up 3, right 4 gets me to that point. Okay, midpoint. So I'm going to use this formula. I'm averaging, oops. So x1 plus x2, average them. 2 plus 5 and average them. So this is 2. 2 divided by 2 is 1. 7 divided by 2 is 3.5. So 1 comma 3.5 would be located right there. Does it look like it would be right in the middle of the distance between those 2 points? Yes. Okay, and the distance, so here's your formula. nice work is that we've actually kind of done those numbers, but we will fill them in. So if I subtract the x's, I get 3, subtract -1. And if I subtract the y's, I get 5, subtract 2. Okay, so we already have all these numbers. We had a 4 and a 3, so 4 squared plus 3 squared is 16 plus 9, 25. So the distance between them is 5. Okay, and like I said, you can think about Pythagorean theorem. 4 squared plus 3 squared, so that's 25. So this hypotenuse is going to be 5. Okay, we will do one more of those. So 2, 9, and 7, -3 are your 2 points. Okay, so physically graphing them. There's 2, 9. And 7, -3. Okay, so the slope okay, so there's my labels, xy of the first point, xy of the second point. So the slope is the differences in the y's, so -3 minus 9, over the differences in the x's. So that is -12 over 5. So if I'm here, and if I went down 12, right 5, I would get there. Okay, so if I went from the first point to the second point, I'd have to go down 12, right 5. And physically that makes sense. Midpoint, so add the x's, add the x's and divide by 2. So 9 over 2 is 4.5. And add the y's and average them. So 6 over 2 is 3. So 4.5, 2, 3, 4.5, comma 3 would be there. Does it look like that would be halfway between? Yep. And the distance is the square root of, and actually we've already done those calculations, -12 squared plus 5 squared. So in a distance manner, positive and negatives don't matter because you can't really actually have a negative distance, right? So 144 and 25 is 169. So square root of that is 13. So those are 13 units apart.